Okay, we're going to return to the fun with undetermined coefficients. So the differential equation we were after was this one, dy dt equals 3y plus t. But I'm also giving you an initial condition, y of 0 is equal to 5. Now in the previous video, we worked out what the analytic solution should look like. Some constant times an exponential coming from my homogeneous piece, and some linear function coming from my non-homogeneous piece. What we're going to do now is use the initial condition and use the particular solution to figure out what the constants are. So if I use the initial condition, y of 0 is equal to 5, so that means I can say 5 equals, and I'm going to put zeros in for the t's, so that's c naught times e to the 0, well that's 1, plus c1 times 0, plus c2, well that tells me that's c naught plus c2 is equal to 5. So there's one equation that I have. Now, undetermined coefficients, the name says I've got coefficients that are undetermined. Well, I've got an equation that at least relates two of those three now. Let's see what else we can do. If I take the particular solution and put it into the differential equation, I'm actually going to get some expression that tells you how the constants in the particular solution should behave in order to be a solution to this differential equation. So if I do that, well, let's see here. My y particular prime, because that's going to be the left-hand side here, my y particular prime is just c1. My y particular, if you recall, is c1t plus c2. So in the differential equation, I get c1, that's my derivative term, equals 3 times, there's my 3 times, c1t plus c2 plus t. And now if I gather all the like terms together, so this is 3 c1 plus 1 of the t's, and 3c2, that has to equal c1. Finally, we're going to play this little game that just says, well, okay, this equal sign's got to always be true. So I'm thinking of this as a linear function over here on this side. Well, why don't we make that a linear function on the other side? And now I'm just going to match coefficients. I know that 3c1 plus 1, the coefficient of the t's, has to be equal to the coefficient of the t's. And the constants, 3c2, has to be equal to the constants on the other side. It has to be equal to c1. So now I have 1, 2, 3 equations and 3 unknowns. The rest is now an algebra problem. I can solve for c1, it looks like, straight away. So this is c1 is equal to a third. Okay, that's fine. But this tells me that 3c2 is equal to a third, which tells me that c2 is equal to a ninth. And if I come all the way back up here, I got 5 is equal to c0 plus a ninth. So c0 is 5 minus 1/9. So now what I have is 1, 2, 3 coefficients, which I've now finally nailed down. I've determined the undetermined coefficients, and I can come back over here and write down my solution. Y of t is, let's see, c0 is 5 minus 1/9 times e to the 3t, plus c1 is a third, and c2 is a ninth. And there's my final solution. Now you should of course double check this. If I put 0 in for t, I should get 5 out. So if I put 0 in, that becomes a 1, that becomes a 0. I've got 5 minus 1/9 plus 1/9, I get 5 back out. So at least I have a sanity check there. The only other thing you should do is now plug this into the differential equation itself. and check it. I'm going to leave that up to you.